This pattern blows my mind because it's pretty awesome. It's time to talk about the bridge pattern. Now, if you've been following this series, you're now probably feeling, wait, what the bridge pattern? In the previous videos, I've been saying that this video was going to be a comparison video between a few structural patterns. I'm sorry, apparently I lied. This is what happens when I don't really think about what I do before I get started. Hopefully what's about to come is better, because that's not the only correction I want to make. Here's the second one. In the previous videos, I've been saying that what we're doing in this playlist is that we're walking through all of the patterns in this book, Headfirst Design Patterns. But in the comments when I talked about the comparison video, somebody mentioned bridge pattern. And then I realized, actually, bridge pattern is part of this book, but not part of the main portion of this book, but rather part of sort of the extra patterns that are almost like an appendix. I mean, they're just kind of shortly mentioned in the end. So this book thoroughly talks about a few patterns and then not so thoroughly mentions a bunch of other patterns. Of course, in this classic Gang of Four book, you have sort of a lightweight explanation of almost any pattern, because it seems that you peeps actually appreciated the contents in this playlist. And by the way, thank you super much to everyone who's watching the videos in this playlist. Because of that, I'm wondering why I should limit myself to only talk about the sort of main patterns from this book. I mean, the original intent from my side was to just talk about the main patterns in this book and not go into the extras. But now what we're going to do is that we're simply going to take all of the patterns mentioned in these books. Honestly, I haven't checked whether there are some patterns that are mentioned in Headfirst that are not mentioned in the Gang of Four book, or vice versa. But in some kind of semi-structured order, we'll make sure to get through all of the patterns. Hopefully you agree that that's good news, and you will forgive me for changing the order of the videos. But enough of that. Before we get started, let me just mention, as usual, if you are new to design patterns, get this book. Headfirst Design Patterns. Super pedagogical, lots of images, spends a lot of time in each of the patterns that it actually thoroughly explains. And I guess the point is that they call it Headfirst for a reason. They try to think about how we learn, and they're not just trying to bash contents into our brains. Links in the description. If you're not new to design patterns, or if you're more like the reference kind of book person, get this book. Design Patterns, Elements of Reusable Object-Oriented Design by Gang of Four. Old, but super classic. You can't go wrong with this book. And if you're looking for world domination, I would suggest that you get both of the books, because how will you dominate the world if you are not, I guess, the most expert in design patterns? Moving on. But now let's talk about bridge pattern. Because the bridge pattern is an extra pattern in this book, they don't have a definition. So let's instead read the definition from this book. The intent of the bridge pattern is to decouple an abstraction from its implementation so that the two can vary independently. Let's replay. The intent of the bridge pattern is to decouple an abstraction from its implementation so that the two can vary independently. Usually I try to decode these explanations, but to be perfectly honest, this confuses the heck out of me. I mean, in my mind, this just sounds completely bonkers. If you think about it, what we're saying is that we want to decouple an abstraction from an implementation. So let's say we've got an abstraction which is animal, and then we have implementations that are concrete animals, so dogs and cats. Dogs and cats inherit from animal. Animal is the abstraction, and dogs and cats are the concretions or the implementations. And then we're saying that the implementations or the concretions can vary independently of the abstractions. I mean, what does that even mean? Does that mean like we can change the method names or something like that? I mean, I'm sorry, I'm just confused. If somebody actually sharply knows what this means, please do shoot something in the comments. But if I would try to understand it, here's the way I would think about it. So if it's about decoupling an abstraction from an implementation, we first need to have an abstraction and an implementation. So let's say that we have an abstraction which is I animal, and we have an implementation which is dog. So dog inherits from I animal, or let's just say animal is the abstraction, dog is the concretion or the implementation. So I guess what they're saying is that this is somewhat coupled, in the sense that what if I animal declares that to be an animal you need to have a speak method. So dog needs to implement a speak method. But that means that dogs have to follow the interface animals. So if animals would change, that means dogs have to change. So if animal would introduce another method, which is, for example, move, then that means that dogs now have to implement move, which means that dogs have to change whenever animals change, which means that they can't vary independently. Now, again, I'm not necessarily sure that this is a sensible way to think about the problem that the bridge pattern is trying to solve. So bear with me. I think it makes sense that we just dive into the actual workings of this pattern and then think about what the intent is. Because I think about it more as decoupling an interaction. So more like adapter pattern. Because adapter pattern, you stick an adapter in between something so that you can vary two interfaces independently. But I've been sort of Googling around, and it seems that people say that adapter pattern is usually added ex post, so it's usually added after the fact, whereas bridge pattern is applied precautiously, or it's applied beforehand to allow yourself the flexibility, to give yourself the flexibility for the future. Adapters you apply when you have a problem, bridge pattern you use to avoid that kind of problem. But I really think about it as the interaction being the key. Let's move on, but let's start in this end. Let me remove this stuff. Why is it called the bridge pattern? It's called the bridge pattern because it looks like a bridge. Here's the thing, let me draw the UML diagram. You've got one abstraction here, any number of concretions here, and any number of concretions here. Let's draw the arrows. This down here is a concretion of this first abstraction. This down here is a concretion of this abstraction. And then what's the relationship between these? Well, this abstraction has something of this abstraction. And this is why it's called the bridge pattern, because it looks like a bridge. Pillar, pillar, plane. So let's use the terminology from this book. So they call this an abstraction, and they call this an implementor, and then they call this a refined abstraction and this a concrete implementor. But that just seems unnecessarily confusing, so let's call this a concrete abstraction. They might have said refined to emphasize that this is probably an abstract class rather than an interface, while this is an interface. But whatever, I mean, this is abstract, this is concrete, this is abstract, this is concrete. So here we have concrete abstraction, and here we'll have concrete implementor. And of course, we could have any number of concrete abstractions here, and we could have any number of concrete implementers here. Obviously, we'll talk about this in more detail, but probably you can start to see now why they're using the term decouple the abstraction from the implementation. So if this is an abstraction and this is an implementation, then they're now decoupled in the sense that you can have any number of implementations and you can have any number of abstractions, and you can pair these up in the sense that an abstraction uses an implementation. This abstraction makes use of an implementation, and for this to work, if this is an abstract class or an interface, probably an abstract class, then this abstraction needs to be any one of these concrete abstractions, and any one of these concrete abstractions, in order for this arrow to work, needs to have an implementor. But seeing that the implementer is an interface, we need to have, or it needs to have, one of the concrete implementors. So this is a pairing of a concrete abstraction with a concrete implementation. And if you think about that, this is actually quite interesting. If you think about the term Cartesian product. So, sorry for going math on you here, but so the term Cartesian product is used to describe a set that's derived from two other sets. Super quickly, just think about this. Let's say that you have set 1, S1, which contains A and B. And then you have set 2, I'll say S2, that contains 1 and 2. So both of these sets have two elements each, and the first one contains A and B, and the second one contains 1 and 2. So what's the Cartesian product? Well, the Cartesian product is a new set of all of the combinations. You can kind of think of it as a multiplication over sets, or the set of all ordered pairs. So what would the Cartesian product of this be? Well, it would be the set of the pair A1, the pair A2, the pair B1, and the pair B2. The reason I'm saying this is, think about this. What would happen if we added another element here into both of the sets? What if set 1 contained ABC and set 2 contained 1, 2, 3? Okay, now we had to add a lot of more stuff to the Cartesian product here. Now, it's not just enough to have A1 and A2, now we also need to have A3. And then we have B1 and B2, but we now also need to have B3. But we need to do the same thing again for C as well. So we need to have, in this same set, we also need to put the pair C1 and C2 and C3. So you can see how as we add more elements to these sets, the number of elements in the Cartesian product exponentially increases. But what does this have to do with the bridge? Well, if you think about it, this is set A, and this is set B. Or sorry, I should say this is set 1, and this is set 2. So, I mean, if you think about what we said before, we want to be able to pair up any of the concrete abstractions with any of the concrete implementations, or any concrete implementors. Which means that if we have 10 concrete abstractions here and 10 concrete implementers here, the Cartesian product is going to be huge. This doesn't really seem like any kind of problem because we started in this end. But if we hadn't extracted these into two different pieces that could be composed together, right? That's the key point. Think about composition over inheritance. We're saying that anything from here can be composed with anything here. You can take any concrete abstraction and pair it with any concrete implementor. So let's just think about it this way. When we had 3 here and 3 here, how many ordered pairs do we have? Assuming I did this correctly, we have 9. But we don't have 9 classes. We have 3 classes here, 3 classes here, and that's enough. We don't need to build 9 classes. And that's the key point, because as these start to become more, we could potentially have a huge problem if we would have to create the 9 classes. Let's look at a concrete scenario so we can see why this would be useful and what the potential problem would be if we didn't do it this way. Let's remove this stuff. So here's the example. Imagine that we're building some kind of app where we have a screen where we want to show different kinds of media products. Let's say we want to showcase books, songs, albums, artists. Maybe you've used the app Spotify. If you think about that, like in Spotify, in some list views, artists and playlists and albums are sort of mixed together. Like they look sort of the same, but if you click them, you end up in different locations. So UI-wise, I mean, that's not really a strange thing. It might be very interesting. So we have all of these different sort of media types or media things, and we want to display them on different pages. But we don't just have different media types, we also have different ways of displaying these different things. So let's say that we have, just to make it simple, let's say that we have short form and we have long form. And if you think about it, this is actually not that contrived. I mean, sorry, maybe that makes me a douche, but I would think that that's actually kind of a good example. Let's just think about it in terms of a UI. Like maybe something like this would be the long form view. So like, I don't know, like here's a record album from some happy dude, and here's some text from that album, and here's a button that takes you to that album. And then there's a short form view where maybe we just take this image and we overlay maybe some title above it. Of course, we should have had some title here just to make it a bit more complex. Yeah, so actually let's add the title here just to make it a bit more complex. So here is the title. Let me color that. And so this is the title as well. Now I didn't draw it that way, but let's say that size would be different. So let's say that the image here is smaller, and maybe we're displaying this on the web, so we don't want to take, so maybe if this is, I don't know, 150 times 150 pixels, we don't want to take a picture that's 300, for example, times 300 pixels and then scale it down. We actually want to show the 150 image. And here we instead want to show the 300 times 300 pixel image. So I mean, this is just some arbitrary stuff, but I'm trying to emphasize that there are different views, right? Let's call these views. So this is the long form view, and this is the short form view. But then we also have the different media types. So let's make it simple. Let's just think about, yeah, let's make it super simple. Let's just think about artists and books. Let's say. So an artist, as in a musical artist, right? An artist that has a song and we have a picture of the artist and the artist has a name. It could be a band, of course, but whatever. And then maybe a biography. And the book has a title and again, an image and maybe the cover text of that book. So they're similar, but they're also different. So what we're saying now is that we want to be able to take any arbitrary media type. Actually, I should stop saying media type, since media type actually means something in regards to the web. So let's instead say a resource, or even media resource. So these things are media resources, and these things are views. They're ways of representing. And what we want to be able to do is we want to be able to take any arbitrary resource and combine it with any arbitrary view. I mean, that's not a strange requirement, right? We want to take any of these and combine it with any of these. So an artist can be displayed in this way or in this way, but a book can also be displayed in this way or in this way. And if you think about it now, this is why we talked about the Cartesian product. If you think about the Cartesian product, this means that we have what pairs? It means we have long form artist, we have long form book, we have short form artist, and we have short form book. So if we would build this sort of specifically, we would need 4 classes. So I'm sort of glancing over a bit of the details because we haven't really looked into the scenario in detail. But the point here is of course that artists, for example, behave differently from books. Think of them as adapters. So what if the artist isn't actually the artist object, but the artist is an artist resource that adapts to from the artist interface to the resource interface. And the book does the same thing for books. So it adapts from the book-specific interface to the resource-specific interface. Because resources need to have a uniform interface, and views need to have a uniform interface if we're going to make the bridge pattern work. So any particular book resource perhaps contains a reference to a book object, and the book object maybe has a method that gets you the back cover text and maybe an excerpt, so like an excerpt from the book, a short snippet from the book. So those are 2 methods that are book specific. So the book resource maybe needs to call book.cover text, for example. Whereas artist does the same thing for artist. So artist maybe has a reference to an artist and it calls .bio, for example. I'm saying bio to denote biography. So you can get the biography of the author, and that's an artist-specific thing. So again, like maybe this is not necessarily part of the pattern now. I'm just giving you a lot of context so that we can have an example that makes sense. But so maybe you have 2 other classes, one which is an artist, for example, and one which is a book, right? So this is an artist media resource, and this is a book media resource, not an actual artist or not an actual book, right? So this is a resource. These are part of the resource interface. But maybe then again, we have an artist and we have a book, and these 2 things don't have anything in common. Or, I mean, they might have things in common, but they're not sharing a common ancestor. They are not interchangeable. You can't just take an artist and then exchange it for a book. And I guess we could have very good reasons for that. It would be potentially dangerous to say that artists behave exactly as books. Think about the interface segregation principle. The interface segregation principle states that clients should not be forced to depend on methods that they do not use. So books should not be forced to depend on the method bio just because artist wants to have the method bio. Because books don't have biographies. Authors of books have biographies, for sure, but books don't have biographies. So we might have very good reasons for not mixing artists and books, like they might actually be separate. But in this scenario, we want to be able to somewhat equivalently treat artists and books in order to extract some pieces of information. And that's when we treat them as media resources. So a media resource that contains an artist is an artist media resource, and it's in some sense just adapting over an artist. And a book media resource is adapting over a book. So the reason I introduced this sort of adaptation portion of this example is that it's necessary for the example that the artist media resource is different from the book media resource. Their implementation needs to be different. Otherwise, there is no point in having the bridge pattern. But let's now move on. So in this particular example, if we built this using the bridge pattern, this would mean that we would have 4 classes, except for the abstract classes or the interfaces. We would have an artist media resource and a book resource, and we would have a long form view and a short form view. So we'd have 4 classes in total. Now, if we would not do this using the bridge pattern, by instead just building a class for every item in the Cartesian product of these 2 sets, we would also end up with 4 classes. Probably. But again, the key point is that as we extend it, if we would add another thing here, we have artist and we have book, but what if we also add album? Or as we talked about before, what if we add author? Then that would mean that the Cartesian product is now 4 times 2, right? Previously we had 2 times 2 giving us a total of 4 classes that we had to build. But as we've extended this now that our media resources are artist resources, book resources, album resources, and author resources, in other words 4, and then we have 2 types of views, 2, then the Cartesian product of that would have to be 4 times 2, in other words 8. So we'd have to build 8 classes. But if we stick to the bridge pattern approach, we simply have 4 types here, we have 2 types here, so instead of having 4 times 2, we have 4 plus 2, which is 6. So less or fewer. And as you scale this up, the payback gets more apparent. Of course, this all assumes that there is something in artist that is specifiable without knowing whether the artist will be combined with a long or a short form view. Conversely, it also requires that the long form view, in other words, the views, that there's something that is specifiable for that thing without knowing whether it will be combined with an artist or a book. So we need to be able to specify artist resourceness in isolation, and we need to be able to specify viewness in isolation, and then let the view delegate down to the resource whenever it needs to access some information from the resource. So think about this. This is what we were doing. We would say there is the notion of a view. It doesn't matter whether it's a long form or a short form. The notion of a view entails 2 things. One, that it is showable. It has a method called show, for example. The second one is that it has, remember that we did when we drew the bridge, we said that this abstraction has one of these abstractions. And that's what we're talking about here. The view has a resource. I'll just put resource here. So those are the 2 things that we're demanding from the view. And what we're demanding from the resource is that the resources have a unified interface. In other words, here we're not coupling to any particular concrete resource, we are coupling to the notion of a media resource. We're coupling to the abstraction media resource. This means that we can create any number of different views. Long form view, short form view, scrollable view, pop-up view, whatever. And the view is responsible for asking the media resource for information whenever it needs it. So the media resource will expose a bunch of methods. Here we said that artists, not artist resources, but actual artists, have the bio method and books have the cover text method. But if we try to generalize this notion is maybe something like a summary or a snippet. Let's call it a snippet. So a media resource maybe defines that, and then I don't mean a concrete media resource, I mean the media resource interface says that the notion of being a media resource requires that you expose a method called snippet. So you need to be able to ask a media resource, what's your snippet? And the artist media resource will ask its underlying author for the bio, while the book will ask its underlying book for the cover text. But in terms of a media resource, we refer to these as snippets, which means that the long form view, if we talk about it concretely, the long form view, since it is a view, it has a resource. And since a view has a resource, it can delegate to the resource that it has. It can ask the resource, let's say that it's an artist resource, when it needs to display this text, it can delegate down to, or if you think about the bridge, over to, rather over to than down, over to the artist if it's an artist, and ask it for its snippet. The same thing goes for the short form, but the short form doesn't want the snippet, so it simply doesn't ask the media resource for the snippet. And if you think about the interface segregation principle, we are now not breaking the interface segregation principle stating that we should not be forced to depend on methods that we don't use. Because that states that when you have an abstraction and multiple concretions of that abstraction, let's say there's the abstraction A and the concretion 1 and 2, then the abstraction A should not define methods that 1 does not want, methods that are unapplicable for 1, just because 2 wants them. So the interface segregation principle is trying to zone down on issues where we're using inheritance in an improper manner. Like, if 1 doesn't want to have a particular method, why do we say that it implements the interface A? If A-ness is defined as implementing this method, and 1 only wants one of these methods, then why are we trying to say that 1 is an A? It's not, if it doesn't actually want both of the methods. So that's a slight divergence, but the point I want to emphasize is again that the fact that the short form view don't use the snippet method from the media resource does not mean that we're breaking the interface segregation principle, because it's not that the short form view does not want to implement one of the methods that it's forced to implement from above. It's that the short form view has something, and it doesn't want to use all of the things that the thing that it has. Ugh, sorry, this is very confusing. Think about the bridge. Here are the views, and here are the resources. And what we're saying now is that some of the concrete views don't want all of the methods that the resources define. So resourceness is defined as having this method, and this method, and this method. But if we look at any concrete view, they might only be interested in 1 or 2 of all of the methods that define viewness. And that's not breaking the interface segregation principle. Okay, so I want to redraw the UML diagram, but this time around we're going to draw it and use the terms that we've used in this example. Then I want to quickly look at some pseudocode, but before we do those two things, I want to quickly just mention again how we would probably approach this if we didn't use the bridge pattern. If we instead had to actually use this Cartesian product, we would probably end up doing something like creating the class long form artist resource, and then long form book resource, and then short form artist resource, and then short form book resource. Whew. And of course, this would just get worse as we're adding on more resources and more views. Perhaps more importantly though than the whole complexity point is what we talked about before when we said that the important point is that there has to be some resourceness that is specifiable outside the context of which view it will be viewed in. Conversely, there has to be some viewness, some implementation details of a view that is specifiable without knowing what underlying resource it will use. And this is really the key point. This is kind of back to if you watched the first strategy pattern video about sharing behavior sideways. The really devious problem about going down this Cartesian product route is that there is some behavior that is actually the same, that is duplicated across this long-form book resource, which is kind of indicated as we can see by the repetition of the name. Like, this notion of long-formness is duplicated across long-form artist resource and long-form book resource. So when we want to change the notion of long-form, let's say we accidentally introduce a bug in the long-form code, we have to go to 2 places and change it, because it's not just that the long-form is broken, it's that the long-form code that's embedded in the long-form artist resource is broken, and the long-form code that's embedded in the long-form book resource is broken. And again, if we had more things like, I mean, it might be completely reasonable that we have artist and book and album and author and song and playlist and whatever. We would have duplicated that code over a lot of places. I mean, we'd scatter that code. And I'd say probably that's the really important thing that we're trying to avoid, rather than having to create lots of classes. I mean, if we created lots of classes that actually do specific things, that do different things, then we can't share them. I mean, it doesn't matter if the Cartesian product is large. If there is no actual underlying structure to the way the behavior is split, how could we possibly merge it? I mean, if it can't be composed, it can't. But the key here is that we have behavior that can be composed. We can extract it into reusable pieces and then reuse it. So we should really do it. If you're facing a Cartesian product problem and you can't actually compose behavior, if there isn't actually any sort of reuse across, I think this is more a problem that's suitable for visitor pattern. but I might be wrong, and I guess we'll see that when we dig into that pattern in more detail in the future. So remember to subscribe so that you won't miss that. Stay tuned. But now it's really about time to redraw the UML diagram. So let me just remove all of this stuff. So there's been quite a lot of repetition, so I'll move fairly quickly so that we can get into the code. Here's the thing. Let's redraw the bridge. We had abstraction number 1 and abstraction number 2. I'm leaving some space over here because we might actually want to introduce the adapters to make the scenario a bit more complete. Then we had a number of concretions here and a number of concretions here. And then we had an implements arrow here, an implements or is a arrow here, and a has a arrow here. Let's now put down the names. Previously, we talked about this as the abstraction, the concrete abstraction, the implementor, and the concrete implementor. So an abstraction has a single implementor, but an abstraction is abstract. So for an abstraction to be used, we need to use any of the concrete abstractions. So here we could have multiple concrete abstractions. And an abstraction has an implementer, but the implementer too is an abstraction. So any concrete abstraction here needs to actually have any concrete implementor. And again, we're saying any because we might have multiple implementors. But let's now use the terminology that we used in the different example. So these would be views, and these would be resources. I'm saying resource instead of media resource just to save space. And then this first view could, for example, be long form view. And I'll just put long form to save space. And then etc, etc. I mean, the second one could be short form view. And then the third one could be snippet view or thumbnail view or whatever. I mean, we have a bunch of different views. Then over here on the resource end, on the resource portion, the concretions of a resource, what are these? Well, this could be, for example, an artist resource. But remember, we had artists, we had books, we could have movies, we'd have songs or playlists or whatever. But here's an artist resource. And this is outside the scope of this pattern, but I just want to say that when we talked about the whole adaptation portion, when we were in this end of the whiteboard, and we said maybe the artist actually adapts over an artist, then I really meant a concretion. So let's say that we have a concretion here called artist, then this artist resource would have an artist and not an abstraction that is shared amongst these resources. I mean, hypothetically it could be, right? But that's not necessarily the point here. So, and if the second one was a book resource, we might have another class which is a book, another concretion, and the book resource has a book. So the artist resource adapts over an artist and the book resource adapts over a book. Again, those pieces we use just to sort of make a more complete example. But the point is that the artist resource is somehow behaviorally different from the book resource and so forth across the resources. There is some behavior that is fundamentally different. As well as here, right? The point is that there is no sharing across these concretions, that the long form is fundamentally different from the short form. And this is really it, except the methods. So we didn't really talk a lot about the methods, but I think we mentioned something like this. We said that the view has a method called show, and let's say that it returns a string, which is the HTML representation of this view, just an example. But it returns a string and it's called show, takes no arguments. So let's say that this view is an abstract class rather than an interface, because then we can specify that this view has, as a constructor, so let's say view that takes an argument which is a resource. So to construct a view, you need to pass it a resource, which means that this view upon construction definitely will have access to something which behaves as a resource. Which means that any concrete view can, as we talked about before, delegate to any of the concrete, or can delegate to the concrete resource that it has access to. And then if the long form is an implementation of this abstract view, we will here override string show. We will here override. So here we just specify that to be a view, you need to have the show method. And here we say a long form view has some particular implementation of the show method. And so forth for the others. The short form view will have a different implementation, the thumbnail view will have a different implementation, and so on and so on. On this side, we didn't really talk much about the interface, but we mentioned the snippet method. And we talked about an image as well. So let's say that it also has an image. Sorry, I'm not specifying the return types because it's not super relevant, but let's also say that we have, what did we have in that picture? I mean, we had a title, right? So a title, I guess we had a link, so maybe we have a URL as well. Some stuff like this, right? So the notion of being a resource requires you to implement these methods. And since the view then couples to the abstraction resource, any concrete view can then be certain that whenever it has access to a resource, whenever it has access to any concrete resource, that resource will be able to respond to these methods. It will be able to somehow give it a snippet, somehow give it an image, somehow give it a title or a URL. And those concrete resources, they are responsible for how to actually implement that. So this we would probably make an interface. Let me just put I as an I resource here to denote that it's an interface. So then all of these different resources, concrete resources, such as, for example, the artist resource, need to implement these methods. So it needs to implement snippet, image, title, and URL, like so. And the same goes for all of the other resources. And that's really it. So to go back to the definition from this book that states that the intent of the bridge pattern is to decouple an abstraction from its implementation so that the two can vary independently. I guess that's what we've done here. I mean, again, I'm a bit confused about this, so I don't want to dig too much into that. If somebody has a good explanation, please do absolutely shoot that in the comments. That would be massively appreciated. But I mean, so I guess these implementations now vary while the abstractions vary, something like that. I mean, again, I'd say that this is a pretty strange statement. I think it makes a lot more sense to just think about it as that we have two inheritance hierarchies or two polymorphic hierarchies. We have sort of the views and we have the resources, and views have resources. And you can compose any view with any resource. So there's a book called Design Patterns Explained Simply that's available on the site Sourcemaking. Check out the link in the description. And it's super good. And the guy who wrote that book says something along the lines of that the bridge pattern separates the platform specific from the platform independent. And I think that is more of a sensible way to see it. So we're separating the platform-specific stuff from the platform-independent. Or maybe I should say the platform-dependent from the platform-independent. So lots of examples of bridge patterns are from UIs that you're trying to make platform independent, and probably this is why we're talking about platforms. So like we separated the stuff that is specific, we separated the stuff that is artist specific, and we have stuff that is book specific and stuff that is playlist specific. So we've separated that into its own inheritance hierarchy where we keep all of the specific stuff. But then on this side we have the platform independent stuff. We have the stuff that's the same across the board. Like regardless of which one of these platform specific solutions you have, you can always do some particular things. Like you can always, I mean, when we want to display a resource in a long form format, that long form format largely looks the same. There are just some specifics that are different, and the specifics that are different is whether we're getting some stuff from an artist or whether we're getting some stuff from a book. But there is really a lot of stuff that is independent, that is platform independent. And that is again like the view actually looks like something, and that view is sort of the same regardless of whether we're displaying an artist or a book. So that explanation I think also kind of makes a lot of sense. So before we wrap this up, let's super quickly look at some pseudocode. Okay, so let's start with the abstraction, in other words, the view. So we've got an abstract class called view that already has a constructor, public view, that takes from that side that we haven't specified yet something which is an, let's specify, I resource. So not just resource, we'll actually explicitly say I resource to denote that it's an interface. It takes an I resource, let me call it R just to save space, I'm terribly sorry about that. And what this constructor does is that it assigns to an instance variable. It says this dot resource equals this R that we were passed in. Close the constructor. And then I need to specify this variable. So the abstract class view has an instance variable that is of type I resource, and is called resource. Ooh, no space. Okay, good start. Then the view needs to have a method, which we mentioned before, which is show. So it needs to have a public method that returns a string. Remember, we said it returns a string because we want an HTML representation in a string format. Maybe not a sensible choice, but whatever, it's just part of the example. Bear with me. So public string, the name of the method is show, and it takes no arguments because it already has all the stuff it needs, and we have no implementation because we need to override it in the subclass. Now, maybe you need some other syntax here in order to define that it's a method that needs to be overridden, but whatever, pseudocode. That's it for the abstract class. The abstract class has 3 pieces. It takes a resource through the constructor, and it sets that resource to its own instance variable of type resource, and then it specifies that to be a view, you need to implement the method show. Next piece, let's specify the first view. So one view would be, let's only specify one. We say a class, which is, let's say long form, and I would name this long form view, but in order to save space, let me just say long form. So the class long form is a view. Open that up. So because it is a view, it gets this constructor, which means that it has access to an instance variable which is of type resource and is called resource. But we need to specify, we need to override this method show. So let's say public override string because it returns a string and it's called show. It takes no argument because it has all the data it needs. Let's open it up. And what does it do? ... Let's not care about that here. Constructing this HTML would probably be a bit tricky. And I mean, it depends completely on what you're doing in your scenario. But the key point, right? The key point of what happens here is that the long form would access, let's say, if I remember correctly from the image we drew before, would access the image, the title, the snippet, and the link. I won't put out all of these, right? But let me just put one so that at least we've touched upon one of them. So what it would do is that it's somewhere in the body of this method would access this dot resource. In other words, the resource that it was passed through the constructor, this dot resource dot snippet, for example, because that's the one we talked about the most. So it would access this snippet and somehow make use of it so that it in the end can return some HTML string here. So this method, let me close this here. So the method show does a bunch of stuff and somehow interacts with this resource that it's been passed, and at the end constructs some HTML and then returns that HTML. Let me just close the long form class as well. So again, and then we would do the same thing. We'd have another one which is short form, we'd have another one which is thumbnail, and essentially they all do the same thing. They implement the show method, but in the show method, they have their own magic. They have their own way of displaying something. And that's the point. That's what we're trying to encapsulate in one of these views, the specificness of this particular concrete view. So that's it for the views. Let's now move over to the concretion. I mean, this was the abstraction in the bridge. This was the left side of the bridge. In the other end of the bridge, on the right side of the bridge, what do we have here? So this was the abstraction, and now on the right side we have the concretion. And the concretion, or the implementation I should say, the implementation we specified, or we called resource. So let's begin by defining this interface iResource. So we have an interface called iResource. We open that up, and what does it specify? Well, we've already enumerated what it specifies before. What it specifies is that to be a resource, you need to respond to some set of methods. These methods are, you need to return a string when I call the method snippet, and a string when I call the method title. Previously we didn't specify the types, but now I'm specifying the types. And then let's say actually also a string when I call image. Let's say that the string is a URL to that particular image. And then finally also a string when I call URL. So what URL do I want to visit when I click this resource? And let's close this up. And that's it for the iResource. That's it for the resource interface. So let's do the same thing on the implementation side as we did on the abstraction side. Let's only write a single concretion of this abstraction resource. And let's pick artist because we probably talked about that the most. So there's a class called artist resource. This time I'll specify resource just to make sure that we're not confusing it with any potential artist class. So an artist resource that implements the interface iResource. And let's open that up. And what does it do? Well, this is super specific to this particular example, but I mentioned that in the example, what we did is that we had an artist resource that adapted over an artist. So this is not part of the pattern, but in our example, our artist resource would probably have to specify a constructor, let's say public artist resource, and in the constructor it would take an argument which is of type artist. Let's just call it A to save space. I'll open up the constructor, and then I would set this dot artist equals A. So I set an instance variable called artist to whatever artist I was passed in, which I called A here. So let's specify the existence of that instance variable as well. So let's say that there's an instance variable of type artist that is called artist. And that's specific to this particular artist resource because we said that the artist resource needs to delegate to a specific artist in order to get the information that it needs. And the reason we did this is that we wanted our resources to be different. So it's just as a part of this example. And then this resource needs to implement all of these 4 methods: snippet, title, image, URL. So let's only do snippet. So we would say public, it needs to return a string, and it's called snippet. It takes no arguments, and it has some implementation. And what's the implementation? Actually, we talked about this implementation before. The snippet method simply delegates to the underlying artist. So it has an artist here as an instance variable that we got passed in through the constructor. And now the snippet simply delegates to that artist instance variable. So we say this.artist.bio. So in other words, the snippet of an artist resource is the biography of an artist. Sorry, I should of course have put return here, so let's actually write return this dot artist dot bio, invoke the method. And then we'll just close this method. And then it's the same thing for all of the other methods. So the artist resource needs to implement title, needs to implement image, needs to implement URL. And it would be the same thing. So let's just, for the sake of the example, we would say public string title, takes no arguments. Let's open that method up. And this method returns a string, and how it gets the string is that it takes something from the artist. So it says, it too says this dot artist, and then it asks the artists for, let's say, its name, actually. Maybe we would even say this dot artist, to save space, I'll just say F name to denote first name, and then we say plus 1 space as a string literal here, and then plus this dot artist dot L name, as in last name, and we'll close this method. So the artist resource implements all of the methods that it needs to implement since it is a resource. And the implementation of these methods depend on what this artist resource actually does. Or I should say depends on what this resource actually does. And this particular artist resource, it adapts over an artist. So the snippet, when we ask it for its snippet, it's delegating down to the underlying artist and asking it for its bio. And when we ask the artist resource for the title, right, the title that we want to be able to use in, for example, the view, then we're delegating down to, or we're actually constructing a new string here that's composed of the first name and the last name of the artist. So you can easily imagine that if we also now had a book resource, title would perhaps be different because we would then simply probably grab just the title of the book. So there's no need for that concatenation. And actually the snippet would probably be different as well because we're probably not asking for a bio, we'd ask for, I don't know, we'd actually maybe ask for a snippet, or maybe we'd ask for the back cover text. And all of this stuff doesn't really matter in terms of the pattern. The point is that every resource is potentially different. Every resource does a different thing. And in our case, we had resources that adapted over some other particular concrete class. So just to recap, we have 2 inheritance hierarchies or 2 polymorphic hierarchies. On one end, we have the view. And on the other end, we have the resource. And in more general terms, in one end we have the abstraction, and in the other end we have the implementation. And if you sort of squint, you'll realize this looks exactly as the UML diagram that we drew in the beginning, or multiple times actually. So here is the bridge, right? This concretion inherits from this abstraction, this concretion inherits from this abstraction, and this abstraction has this abstraction. So the view has a number of different concretions, the resource has a number of different concretions, and every view needs to have a resource. Which means that every concrete view will have some concrete resource. And through that, we can then compose different combinations of views and resources. And the point is that we've then been able to separate the platform specific from the platform independent. So some stuff is specific to an artist resource. But when we want to display an artist resource, there's a lot of stuff that is shareable across different resources. So if we have an artist resource and a book resource, doing the sort of layout stuff when we had this layout with the title here, and an image here, and some text here, and some button here. That actual layout logic shouldn't be nested within this artist resource, because then we'll have a class explosion, and then we're back into that Cartesian product problem. Instead, we should say that let's keep that layout stuff general, and let's say that that layout stuff simply interacts with the resource, regardless of what that resource is. And let's call this a view. So generally it's a view, but specifically this particular view happens to be a long-form view. And this long-form view interacts with the underlying resource, or sorry, I should say interacts with the resource that it has, delegates to the resource that it has been passed upon construction, because it is responsible for simply constructing this view, or constructing this layout, what to actually put in this sort of location, or in this place where we want to have an image, what to actually display there, right? What the URL is for that image. It doesn't know, because that's not part of being this long-form view. Being part of this long-form view is simply just knowing that there needs to be an image here. But what that image is a concern for a resource. So if we pass a view a resource, then the view can ask the resource for that information. It asks the resource for the information that it needs in order to construct this particular view. All right, hope that makes sense. This pattern actually kind of blows my mind. It's like I struggled to figure out an example, but then when I figured out this example, I thought, wow, this actually makes a lot of sense. So actually, I would venture to guess, I mean, I'm really just guessing now, that this pattern actually is applicable in lots of scenarios where we potentially wouldn't think that it is applicable. If we just sort of look a bit under the surface and think really hard on it, probably there are a lot of places where we can actually make use of this pattern. And I mean, if nothing else, this is really just a very interesting pattern, in my humble opinion. So I hope you now feel that you know the bridge pattern. If you don't, or if you have any questions, or if you want to dig down further into something, please do absolutely shoot something in the comments. Always massively appreciated. If you like this video or any of the other design pattern videos, I usually don't say this, but remember to share it with your friends. If you think it's good, that's massively appreciated. Beyond that, remember to subscribe so that you won't miss the upcoming patterns. Since the strategy is to go through all of the patterns in this book, we have tons of patterns left to go through. I appreciate you sticking around to watch the video. Thank you very much for watching, and I'll see you in the next one. Whoa.